Anybody way won't fight you, man, they come, they already know. I'll be right beside you.
You're most welcome to this upload. I continue requesting members that subscribe to my channel, Smart Science, and get the best chemistry you feel like. We are also going to start uploading some of the practical reactions such that we can have our visual guides to take us through the learning, and we get to know what we really want, such that once you see a reaction happening, a reaction taking place, how it occurs, you don't easily forget it. Today we are looking at compounds of carbon. We are looking at the compounds of carbon. Remember, we are under a topic of carbon and its compounds. So today we finished carbon. Today we are looking at compounds of carbon. There are various compounds of carbon which are going to categorize by the following. Number one are oxides. Number two are carbonates. Number three are hydrogen carbonates. And number four are organic compounds. So all these are going to be like chapters, such that we handle one at a time and we see how best we can understand it. These two are salts of carbon. So when we are looking at carbonates and hydrogen carbonates, we have to combine the two such that we don't waste too much time, or we don't do more videos for those two. We have to combine them at once. However, today I'm going to look at one, and my main interest is going to be on oxides of carbon. My main interest is on oxides of carbon. Oxides of carbon. These oxides are two. We have carbon dioxide we also have carbon monoxide. And in today's discussion, I would prefer us looking at carbon dioxide. And this is a gas, carbon dioxide gas. We have to understand that this carbon dioxide gas is written as CO2, that is its chemical formula. Number two, it's a colorless gas. That occupies 0.03% by volume of air. We should know that doesn't support burning. Doesn't support burning, and it is the gas used by plants in photosynthesis. I think with that brief introduction, it takes us to carbon dioxide.
You gotta get up. gotta get up and make a move, 'cause the world will never see you until you do. No, they don't really care what you're going through, so you gotta show them, baby. You gotta show them the real you. You gotta give them what you got. No, don't let them see what you're not, 'cause you are strong. You are wise. You are worth beyond 1,000 reasons why. And you can't be perfect, baby, 'cause nobody's perfect, darling. But no, 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 there's nobody in the world like you. What do you do when you can't let go? What do you say when you just don't know how you feel? And you know nobody knows how you feel, 'cause everybody's got their own damn problem. So everybody's trying to find their way, and day by day is a struggle. In this world, you know you have to hustle. Just know that you're not alone. You don't always have to be strong all by yourself. I said it's okay to ask for help. Now listen, people will find you, but they don't define you. And you will find people who help redesign you. People will find you, but they don't define you. And you will find people who help redesign you. You are a work of art. Bet you didn't think you'd come this far. Now here you are. Baby, you are strong. You are wise. You are worth beyond 1,000 reasons why. And you can't be perfect, baby, 'cause nobody's perfect, darling. But no, 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 there's nobody in the world like you.
So by virtue of the drawing, that's how we can prepare carbon dioxide gas. So whatever we've drawn here, we just have to describe it. Make sure as you're drawing, the delivery tube bringing a particular substance has to touch the solution, but that one driving it away should not touch the solution. So as this one comes into this wash bottle, it touches the solution, but the one carrying the gas away from the wash bottle does not touch that solution. It is left hanging from somewhere. So eventually we collect our dry carbon dioxide gas through downward delivery because it is more dense than air. So what we've drawn here can be represented in terms of a write-up, and eventually we can write an equation to represent the reaction that will take place between this acid and calcium carbonate. Sometimes calcium carbonate is called marble chips, so don't mind about that. As long as you have your calcium carbonate, you can instead write marble chips. It is also okay. Let us see how we can describe the entire process we've drawn or we've represented by a drawing. We've seen on a drawing that we place dilute hydrochloric acid in a thistle funnel because it's a liquid. Then calcium carbonate is put in a flat bottomed flask because it's a solid and no heating is required. The tap is opened to allow dilute hydrochloric acid to mix with calcium carbonate. When the tap is opened, the reaction occurs. At room temperature. The reaction occurs at room temperature with the effervescence of a colorless gas, and that colorless gas is carbon dioxide. After that, the gas is bubbled through water, and the importance is to remove fumes of hydrogen chloride gas. Next, carbon dioxide is bubbled through concentrated sulfuric acid because it's also acidic, thus can't react with the acid. So after drying, it's bubbled through concentrated sulfuric acid to dry. Sorry for that. To dry because it is also acidic, thus can't react with a fellow acid. And lastly, dry carbon dioxide gas is collected by downward delivery because it's denser than air. So that's why we collect carbon dioxide by downward delivery. Lastly, is the equation to represent the entire reaction.
More than a moment, you're more than a moment to me. Don't care where we go as long as